this talk is going to be, I'm going to call it a 3x2. And so the talk's title was Why Design May Ruin or Improve Your Life. And when I say it's a 3x2, it's because we're going to go through 3 topics, and each topic we're going to have 2 points on it. So the first topic is going to be, what is design? The second topic we're going to talk about is how design evolves. And then the third topic is going to be some design tips for developers. So why don't we look at the I also, you're going to discover, cannot spell. And so I started coding when I was very early, in about grade 3 in elementary school, and I coded to grade 8. And by grade 8, I discovered that I was very, very, very bad at spelling. And I was even worse at math. And the combination of the two made coding very painful for me, as much as I enjoyed it. So I kind of shifted more into visual design rather than software development. Partly because, I don't know, there's probably spelling mistakes out there. So, what is design? Anyone, do you want to throw out a definition, or what's it to you? Anyone? Oh, it's hard to explain. All right, so that's one definition. Design is hard to explain. Is it art? Mm-hmm. Pardon? Speak up. It's an architect. An architect would be a designer, exactly. This lecture, we're not only going to talk about what is design, but we're also going to be good practice in speaking louder, like Rubai was saying. And then you'll be all good as public speakers as Rubai is by the end of this. What is design? How something works. Ah, interesting. Interesting definition.
Problem solving.
Pardon?
Problem solving.
Problem solving, exactly. Problem solving, how something works. How does it look? How does it fit? What are some examples of things in life which need a designer? Clothes? Houses? Pardon? Cars? Shoes? Websites. Nice. Anything else need a designer? Is that it? Pardon? Mobile apps? Yes. And so, I think, why are you designers? Who's here a designer? One designer in the room. All right, I'll re-ask you the question at the end of this talk. We'll see if anything's changed, okay? We're all designers. What do you mean?
I think everything needs to be designed.
Yeah, go on.
Everything in life needs to be designed. Where we are is designed. The way we are, the human body is designed. The go out there is designed. And also, for us to do anything, we have to think about what's that about, how can we solve it? If we're trying to solve anything, that means we are all, in some ways, designing.
I agree. I actually have a good quote here. I'm just setting a timer, else we might be here until after lunch. Sorry. I have a quote here. So Steve Jobs, who is a pretty good designer. This is what he said about design. Most people make the mistake of thinking design is what it looks like. People think it's the veneer, that designers are handed a box and told, make it look good. That's not what we think design is. It's not just what it looks like and feels like. design is how it works. And so if there's one thing I want you to take away from today, that is design is how it works. So I think this is a definition of design that you could actually apply to almost any field that we had talked about. So when you think about website design or mobile app design, how does it work? And that's kind of the question you're trying to ask. When you're thinking about fashion design or shoe design or car design, what are you trying to design for? And so I guess the second question then would be, how do you evaluate if a design is good or if a design is bad? What's the criteria that we're going to be using to judge a design, for instance, if this is what our definition is?
A bad design. We can say a design is bad if the user is having a hard time trying to figure it out or how it works.
Yeah, if it's not intuitive, that would be a bad design. I agree. Any other? How do we know if the design is good or bad? How do we know if we have a good mobile app or a bad mobile app? Yes, Debbie.
Does it work?
Does it work? Yeah, does it work? Great question. And so maybe the second point, question to consider to summarize this would be, what is its purpose? What's the purpose that you've designed for? Because, for instance, let's take a hammer. Now, what's the purpose of a hammer? Go ahead. To hammer in nails. So we agree that the purpose of a hammer is to hammer in nails. Yeah? Okay. So if the purpose of a hammer is to hammer in nails, we're going to say that that's what the goal is. And then when we're trying to judge if it works or not, we're going to figure out, well, how good is it at hammering in nails, right? If you design a hammer that had a handle that was this large, and you went into hammer in nails, how easy would that be? Right? Would the user be frustrated if the hammer was this long? Right? So I would say that if the purpose of the hammer is to hammer in nails, and we're asking how it works, that would be a bad design. But if you built a hammer that had a handle that was this long, and you went into hammer in nails, it would be much better, right? So you could say this would be a better design. And so I think there's a misperception that you can never criticize a design, that all design is good, right? That all design is equally good, it's all a subjective matter of opinion. I would say that that's not true, because if you're designing something well, you're designing it for a purpose. And how close you get to that purpose is how effective your design was. So let's think about some other examples. Has anyone been to the washroom in the hotel here up on the second floor, to one of the washroom stalls? Yes. Now, when you went in and tried to close the door, what happened? Maybe it's different in the men's or in the women's, but what happened when you tried to close the door to the washroom stall? Pardon? It was closing itself. There was some trouble with it closing. Did anyone have the trouble that when you walked in and then you tried to close the door, that there actually wasn't enough room for the door to swing and for you to close the door? That you had to stand behind the toilet and then close the door, and then you could, right? Did anyone have to do that? Maybe it's different in the men's or on the women's side, but take a look when you did? Yeah? Okay. It was fine. But I would say that would be an example of bad design. Because the purpose of a door is so that you can close it. And if the door is so wide that it needs a very large area to swing, and if you actually have to stand almost behind the toilet to swing the door closed, that would be a bad design. Do you see where we're going? Now, if we look at these curtains, for instance, there are two types of curtains, right? We have this top curtain, and then we have the second curtain. Now, if I was your user or your client, and I came to you and had asked for a set of curtains to make this room dark so that you could shine a projector, and that if you were, let's say, the developer and came back with this, you've done a bad design, right? But if you came back with this, you've succeeded. You've made a good design. You see where we're going? And so as Robai said, one of the critical things when you're doing user testing or project management is, and as Debbie mentioned this too, is always understanding what does the client actually need? Why are they asked for the software? What's the purpose that they're trying to get at? And so as we think about software development, we're always trying to think, is what we're developing going to achieve that purpose for our client? And so we think that what we do as software developers isn't design. For instance, Fatma is working very, 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 very deep on the back-end architecture of our system. She's working on this Apache Spark and the Apache Kafka pipelines. She's transforming data from multiple tables. You would think that none of that involves design, right? If you're that far into the code, you aren't a designer. But if you think about it, why is she doing this? It's because we want to be able to serve data to the client, to the mobile application, so that it can work offline. And so as Fatma works through this project, she's trying to understand, well, what data does the person want when they're offline? How do we decide what data? Do we do it based on the user? Do we do it based on their location? Do we do it based on the clinic? How much data? Because we want this application to work offline for a long period of time. Do we give them a day worth of historical data? Do we give them a week worth of historical data? These are all design questions. We're trying to figure out what the purpose is. Well, we need this app to go with a mobile community health worker, and they're going to go door to door for 2 weeks. All right, so that's the purpose. And so as much as you try to make your code fit that purpose, you're actually designing. Is that we're on the same page? Cool. One other design example I like to talk about often, this is not my example, this is someone else's, and this is on door handles, all right? And so this is a common example. Now, if you have a door, you can either push it forward, right? Or you can open it up. How would you design a door handle if the door only swung in, if you could only go through the door? How would you design a door handle? And so that would be a door that, let's say you have two doors. You have one door, which you can swing either way, and then you have a second door that you can only swing this way, right? So if you're walking through, you have to push it this way, and if you're coming this way, you have to pull it, and this door you can either push it if you're coming this way, or you can push it coming that way. How would you design the door handle for both situations? Just take 30 seconds and think it through. What type of a door handle do you need? Take a few seconds. If you have a pen or paper, you can sketch it out. Anyone want to share? Anyone want to share their door handle for this door which swings both ways? Or what would your door handle look like? Yeah, this team here. Yes. You don't necessarily need a handle. Ah, interesting design observation. And why? You just push it, right? And so you've seen doors sometimes with just like a metal plate or a plate on it, and you just push, right? There's not a handle. Very good. What about this door here, which you can go one way, you can push, and the other way you have to actually pull it? What type of handles do you need for that? Maybe someone from this side? Oh, actually, go ahead. Yeah.
Okay, from your side, the door, you have an handle on the other side,
handle on this side?
Yeah, and these are not doors. A handle like kind of for sides.
Like a bar that you push, or
Kind of a handle on both sides.
here and here?
No, for the second.
Oh, for this one. Oh, I see. Like a pull handle or a push handle? A pull handle. Ah, so that's a design too. So you, exactly. So you have kind of two options when you're thinking about this. You could say this bottom door swings both ways. We could either put a plate on both sides, meaning you could just push your way through either side, or we could put a handle on both sides, meaning you could open the door and walk through from either sides. Both make sense, right? And you could come up with arguments based on what the purpose of that door is, that either one would be a reasonable option. When you think about this other door, as you mentioned, one side you might just want to push your way through, but the other side you want a handle to pull, right? Now, you couldn't put a push plate on this side, right? The door wouldn't open, right? But the other thing which is important is sometimes a door can't come one way, right? Like this door only goes this way, right? And so if you put a handle on this side to pull, have you ever gone to a restaurant or to a building where you go to the door and you try to pull the handle and the door doesn't open, right? Because the door only goes the other way? That's because the person who put the handle on that door has never thought through this design, right? They never thought about what's the purpose of this door. Well, this is the door that customers, when they walk into the store, are going to push and walk in. But instead, they've all put a handle on that door, right? And so then when you're the customer, you go to grab the handle. What do you do when you have a handle? You pull, and then the door doesn't open, right? And so think of this in software, right? There's lots of things when we're thinking about the user interface design where we want it to be very intuitive. We don't want the customer to push on a door which can't be pushed, or to pull on a handle which actually has to go the other way. And so a lot of the user interface design language which we think in has to be super logical and intuitive. But it's important, and now we'll move into the second part, to realize actually that design evolves. And the point I want you to realize is that design follows technology. So this is design follows technology. This is actually something which I really like this idea. I find it very, very interesting. And the point is that our ability to design, our ability to solve problems is based on the technology we have available. And this is something which people don't realize actually even applies to things such as fashion, art, and architecture. For instance, if I said that the tools you have to design this house are mud, clay, and cow dung, right? Mud, clay, what type of a design are you going to be able to think about as you build that structure? The size of your windows is going to be limited, right? The roof is going to be of a certain material. When you think about design, you could design what's a really good house if these are the materials you have. But now if I said you also can use wood, when you think about how you design that house, your styling is going to change. If I said you also could use steel and you could use brick, the way that that house is going to look is going to change. And so sometimes you see in magazines or online pictures of really weird buildings now, right? Buildings which have these strange curved shapes. Have you ever seen very strange architecture like that? Well, why do they have this strange design? My thesis would be that the designer, the architect, is trying to use the most modern technologies because it's fun, right? If you're a software developer, you always want to go try the newest language, right? You always want to try the newest thing. And so the architects want to use the newest tools and technologies in construction. And so we have the ability now with modern steel manufacturing to pour these very strange steel shapes. And we have the software capacity now on the engineering side to develop the actual forces, right? Because the engineers need to know that that building, which has these strange curves and shapes, is going to be stable and strong. And that needs actually very sophisticated software to be able to calculate those vectors on the engineering. And because we have the software and because we have the manufacturing capability, the architect says, these are really cool tools. And that's why the design follows, looks maybe a bit strange. Same with car design over the years, right? The shape of cars is influenced very heavily by the technologies that we have available over history, the ability to bend different metals and things. Even something as simple as the chair. You know, for centuries, a chair was built out of wood, probably, right? And so the design of a chair was reasonably the same for many centuries. And then you see in the 1940s and the 1950s that new technologies emerged where you can take plywood and you can form it. You can take a sheet which is flat and you can bend it to become more of a chair shape. And so we see throughout the mid-1900s all these designs. They're called Eames chairs. They're very popular in people who study industrial design. But essentially the reason that we got this new design, this new shape of a chair, is because we now have the technology to bend the materials in a way we didn't have before. And then you could also imagine plastic chairs, right? Plastic chairs didn't exist 100 years ago, but the reason we have designs of plastic chairs is because we have new technologies. Now why do we talk about this? Well, as software developers and as people who are trying to solve problems, the technologies that you have are always going to continue to evolve. And so you always need to think about what's the new technology I have, what are the new tools I have, and how can I apply this to the problem? And then that's why we have the second point here, which is that design follows product cycles. Here's an example. Has anyone here ever bought software that has to be installed on a CD-ROM? One, I have. Two, three. All right, three of four.
We didn't buy it.
Oh.
We pirated it.
Ah, you shared it.
Yeah.
You shared CD-ROM software. So when we had desktop computer systems, the product cycle, I would suggest, was relatively long compared to today. You would buy a CD-ROM, you had to pay for the CD-ROM, you had to pay for all the packaging, you had to install it on your computer, and you'd probably keep that piece of software for usually, I don't know, 2 to 8 years or something like that. And so your product cycle was measured at, maybe every 5 years you would upgrade that piece of software. And if you're an enterprise, if you're building enterprise software, so this is software which is being deployed in military and large banks and healthcare and hospitals and in corporate environments, the software there is probably being refreshed maybe every decade optimistically, if that, every 2 decades. Oh, every 2 years. But sometimes like if you go to for instance, to the airport, you'll see that they're still using DOS-based terminals often. And so that software is using a technology which is many decades old. Compare this to your phone. How often are you getting updates pushed on your phone? Twice a week? Twice a month? Yeah. Right? It's using up all of your data and your Wi-Fi. And so because we have, I think, faster product turnaround cycles for mobile, because our websites have much faster turnaround cycles, there was a time when Amazon was pushing an update to their code every 11.7 seconds. They were merging, from their GitHub equivalent, a new code merged into production every 11 seconds. And so my thesis is that because our technology has a very quick product turnaround, it actually allows the design to develop much quicker than old technologies. And so if you look at something like the mobile phone, I think that the user interface design language, which has evolved in a very short period of time, right? We've only had mobile phones with touchscreen interfaces for just over a decade, and certainly they haven't been widespread for a decade, but we've made a lot of progress in the way that that design looks over this decade. And I think the reason we're making so much quick progress is because the turnaround cycles of the hardware as well as the software are very short. And so it's very interesting too, because when you look at desktop software, I actually think that in general, the design language hasn't changed that much between the 1990s, the 2000s, the 2010s. We had the general constructs of menus, folders, icons, clicks, whereas something like the mobile phone, we now not only have buttons, clicks, but we have swipe gestures. And it's very interesting because who here has used Snapchat? Anyone? How do you navigate in the old Snapchat? Not the new one which has buttons at the bottom, but on the old Snapchat, how did you navigate? Oh, you've never used. Okay, just scratch it. All right. Has anyone ever used Snapchat? So in Snapchat, oh, I see a hand. How do you move now? You swipe. And so it was very confusing to people who weren't young. So millennials could figure out how Snapchat worked because they grew up using a design language where you have a mobile device that you swipe left, right, up, and down. And so in order to get to the, I think the chat, you would just, there was not buttons on the screen saying chat, photo, news, like a normal app, right, where you press the buttons and it moves you between the screens. You just would swipe. You just move left, and then you would move over to the chat page, and then you would swipe right, and now you'd be in the camera, and then you'd swipe on the screen again, and now you'd be in news. And so when I downloaded Snapchat for the first time, I had no idea how it worked. I deleted it after about 3 minutes. Whereas apparently everyone who was younger than me understood this design language, right? So this is an example of how design has evolved and is following the technology. The only reason we have introduced swipe in our mobile devices, right? The initial Blackberries, the initial phones never had swipe. They had physical buttons you press. But then Apple, through the iPhone, popularized capacitive touch interfaces, so the ability to press a screen and to move your finger around on it. And this new technology enabled a new type of design, swipe interfaces, and because that technology is being updated so quickly, the design of what we swipe on keeps evolving. And so an example of how that swipe has evolved is, has anyone ever used on a phone or a tablet a Google Chrome browser? And what happens if you're on a page and you pull that page down? Has anyone ever done that? Pardon? It opens a new window. And so you're on the Google Chrome page, you pull the page down, and in the movement of swiping down, a new menu appears. Anyone familiar with this? Yeah. And then if you keep your finger on the device and you move left, it moves to the icon to select left, which is, I think, new page or close or something, and you can swipe right, which is new page. One way you close the page and one way you open a new page. And if you just pull down, it refreshes the page, right? So this is an example of a whole new design language. It's not right in the old system where we didn't have capacitive touch. We would have had to have a bar right at the top of the screen or at the bottom of the screen, which would have the 3 options: close, refresh, new page, right? Whereas now, because we have capacitive touch, you pull your finger down, it reveals a menu, and then you interact with that menu by sliding your finger left and right. Right? This is a concept which is entirely new and entirely foreign, and in fact, most people don't even know it exists because it's so new. And so the tension, as someone who's trying to design things with purpose and to see how they work, is always to say, well, is the technology I'm using so new, and is the design language so new, that although it's a very elegant solution to the problem I'm solving, although it's so simple and beautiful if you know how it works, if most people don't know about that design language, it's actually probably not meeting your purpose well enough. And so sometimes, and this is going to be frustrating for us as developers, sometimes we have to put aside using the latest technology and use an older technology because people understand it better. And so this is where Snapchat, where I opened it up the first time, I had no idea how it works. It's because it was using the latest technology. And if they had just put 3 buttons on the page, I would have known that they had 3 parts to their app. Yes? Please.
So, I don't know if it's
Yeah.
But like, what if you have a new technology, can you just like connect WhatsApp? The way they added the one if you want to reply to someone's text, the one that shows on the top of the reply or the replies that you listen to, that's the one you swipe. Before we used to press for a long while, then it appears down direct, but now you just swipe. The thing they did was, if you press it long enough, it will tell you swipe it. Why can't you? That's a better way of embracing new technology.
I agree.
It's actually, yeah, like adding instruction or rejecting the action that the previously done.
Yeah, I think it's a great observation. And so if you couldn't hear at the other side of the room, what was your name again? Noreen? So Noreen was saying that if you're trying to use the latest technology, what you can do is you can assume how your user probably is going to interact with your application or your website. And when they go to interact with it in the way you think they're going to interact, you can give them some helpful notifications saying we've improved this and here's the new way to do something. And so I think that's a great observation. Yeah, if you're going to try things which are really new or cutting edge, or if you're shifting your product and you're building out and you're changing your features, your user is always going to go to the same page and the same tab that they had for the last 5 years. And if you suddenly removed something from there, you have to allow people to go to the old place and tell them where to find it in the new place. And we run that exact same problem at Ampath with our software as we try to build it better. The very last thing here to talk about is some design tips for developers. And there's going to be two. The first one is something which I'm calling demos. Again, one of the, I think, critical factors that has made Apple very successful is their importance upon what they call demos. And I'm using the term demos as a broad term in this category of mock-ups and prototypes. But a demo is essentially taking something which is an abstract idea and making it more concrete. Now, if I said that I have the most beautiful cow, and then was it Debbie? What's your name? Yeah, sorry? Kathy, sorry. And then if Kathy said that she had at her house the most beautiful cow, and if Fatma said, no, I actually have the most beautiful cow, and then if our developer Nikki, who we know has the most beautiful cow, said that, no, I have the most beautiful cow, we have no way of resolving this if we just got around the table and tried to tell each other why our cow was better than everyone else's, right? But if we each brought a picture of our cow and we put it on the table, now we can actually have a conversation. Right now we can look at the four, we can compare, we can say, well, I think this is better for this reason, this is better for this reason, this is a problem, right? And so this is the big importance of demos in development and design and software. Is the moment that you make either a mock-up or a prototype, or you take this concept which is vague and abstract and you put it on paper, now you've started the conversation. And this is the thing that Apple loves to do. And so life at Apple, I'm not familiar, I've never worked there, but life at Apple as a developer, from some of the books I've read, essentially involves just making one demo, making another demo, and through each demo, you make slow improvements. And through each slow improvement, you actually get to your final product. And so they call this, for instance, there's a book called Creative Selection. And so, you know how, for instance, fish might evolve slowly over time, and then each generation they get, more adapt to swimming in that water? The thought is that each demo over time evolves until you get to the best demo possible. And so it's frustrating working in demos because most of your demos aren't going to succeed, right? You're going to make all these demos, and then you're going to look at it with your colleagues and say, well, actually we can fix this and we can make this better. But that's good. That's because you're now selecting for something better. You're moving in the right direction. And then the last thing I want to talk about is something which I'm going to call a trained gut response. And this is a practical thing that you can do as a developer starting today in order to design better. When you encounter a new situation, or for instance, if you open an app for the first time on your mobile phone, you might have an initial reaction to that app which is fleeting. It might last a few seconds. And your reaction might be neutral. Your reaction might be, oh, looks really good. Or your initial reaction might be, oh, something wrong here. It's the same when you walk into a building. You might walk into a new mall, right? And you walk in and you go, wow, something strikes you. Your initial reaction to whenever you encounter something, you see a shirt in a store, you have an initial reaction. Your initial reaction to this is very short, and it's sometimes neutral, positive, or negative. I would encourage you to pay attention to your initial reactions whenever you encounter something new. Because that initial reaction will be fleeting, will not last long, but it's going to be critical in becoming a better developer and designer. Because what I would suggest is when you encounter something new and you have this reaction, pause, recognize the reaction you've had to it, and then try to figure out, why do I dislike or why do I like this? And what you're going to find is over time, you're going to develop something that's called a trained gut response, meaning that your gut, this reaction you have to something, is going to become better, faster, and actually give you a language to talk about things in. And so when someone gives me an application to look at, I have immediate strong reactions now to it. I say, I don't like this, I like this, change this, do this. And the reason I can give such quick criticism is because I've developed this library of trained gut response. I have this internal library of things which I think work well, things that don't work well. But the only reason I've developed that is through trying to do almost backwards logic, encountering things, saying, oh, this is really cool. But what's cool about it? What about this works well? And you can do this for any type of design you're interested in. And so if you're interested in website design, every time you go to a website and you have this reaction which is, oh, right, who developed this? Or there's something wrong here, think, okay, so I didn't like it. What about this is frustrating? And maybe you'll find that there's something about the menu bar, or that the contrast of the colors doesn't work, or that there's just something off about your interaction with that website. And then even better, when you encounter something that wows you, figure out what wows you about it. And so I think that's kind of the thing which all of us can do every day, just as we live our lives. And then over time, you'll all be much better designers, and that will make you much better developers. Now, one way to shortcut this trained gut response is to study people who already have a really good intuition for designing things. And so if you want to jot down, I'll give you 2 or 3 names to perhaps look up on Google if you want to learn more about people who I think have a really good understanding. And so there's someone called Luke, and I'll write down his name here. I'll spell it. His first name is Luke, and his last name is Wroblewski. Roblewski. He is a software designer at Google, and he gives a 2 to 3 hour lecture once a year. All of his lectures are online, and it's, I think, the best 2-hour summary of the latest technologies in mobile development, which then tells you about the latest design. And so you know how when you go to YouTube now, it loads what's called like a skeleton page? It shows in gray boxes what you see loading. That kind of was a big theme of his last talk. And that's because they realized that users thought that the product worked better when they saw a skeleton page, because they thought the load time was less. And so, highly recommend looking at Luke. You can also look at, there's someone called, so we talked about Luke, W. There's someone called Dieter Rams, and if you search his 10 design tips, you'll find an article, for instance, on Hacker Noon from 2018. Dieter Rams is an industrial designer. He's a German from the 1950s and 60s who developed a lot of industrial products like razors and radios and tape players. But he has a top 10 points on what good design is that I think applies to every software developer. Luke W. And then there's a person called Edward Tufte. And he's kind of a hero of mine. And Edward Tufte is what we'd say is the godfather of the visual display of quantitative information, meaning that he's one of the pioneers in making it easy to show data, to show information on a screen in a way that makes sense to the user. And so he has books and YouTubes and pages and articles, and very cool. And then if you're particularly bored, on my website I write about random things, and it has to do sometimes with design. We're also on Twitter. And so there's, for instance, I was bored one evening and did, I think it was like a 90-minute video on the new Twitter user interface design. And so if you just look on the website and then go to the hashtag on this for design, you'll find a bunch of articles. And there's also a playlist on this website which has all of Luke W's annual talks all in one sequential playlist. That's kind of what I would really point you to. So, to summarize, who here thinks that they might be a designer? I see a few more hands than before. Exactly. And so remember that as a designer, all you're doing is you're trying to solve people's problems by understanding what the purpose that they're trying to fix is. You're going to use the latest technologies to influence the design decisions that you make, and that you want to eventually train yourself over time to understand when you encounter good design and bad design, and to try to replicate the good and to try to avoid the more dodgy design. Sound good? All right, I'm around all day if you have any questions. Thank you.